When TS function is called, TS function defines major units and the physical constants with the simple units too. So after TS function call, you can calculate physical values with units like this. J, go. You can calculate even Groebner basis symbolically. J, go. This time, let's look at vector matrix operations. PythonSf uses a combination of Chiller symbol and square brackets as the extended operator that generates a vector or matrix. The selected character describes a two-row, two-column matrix. This selected character describes the length vector. This selected character describes a multiple assignment in Python and assigns the matrix and a vector to empty or VC variables. This selected character is a PythonSf expression. That means the multiplication of a matrix and a vector. You can calculate the multiplication of the matrix and the vector and the cursor by the J beam operation that we have seen many times. J, go. You can use a tuple or list for the one or the other of the matrix vector arithmetic expression. J. You can simply use the sequence or array without distinguishing row or column vector or annoyingly in MATLAB. PythonSf calculates inner product just only by a multiplication of vector. J, go. Because normal linear product expression in mathematics describe a tuple by the Python syntax, like this. J. PythonSf can deal with the broader algebra other than integer, float, complex one. For example, PythonSf have assigned a Bool field coefficient monomial to backquote P. And you can do for arithmetic and integer power operations for the backquote P. Like this. J, go. Like this. PythonSf can use any Python packages because PythonSf is upper compatible for Python. Particularly, the SciencePy package is used frequently because it implements many features of MATLAB. You should call sy function to use SciencePy package and their sub-packages, because the SciencePy package is very big and consumes seconds just to import the SciencePy package. So you should import the SciencePy package explicitly by calling the sy function. When the sy function is called, then the SciencePy special sub-package is imported too and assigned to the SS label. So you can use any special function in the special packages after calling the sy function. So you can calculate the elliptic function under the cursor by the semicolon j beam operation. Semicolon j. Sorry. Semicolon j. Go. Yeah. PythonSf has implemented permutation groups. It might be useful, though limited for small permutation groups less than SN9, because we simply implemented the program of permutation groups, so it created many substituting instances along calculations, and might spend a lot of CPU time for big order permutation groups. But the limited calculation less than SN9 is practically fast and might be useful for many undergraduate students. Let's try the permutation group calculations. SB2301 is a substituting instance. SB2301 substitutes 1, 2, 1, 2, 3. And SB2301 substitutes 0, 2, 1. Semicolon J. A multiplication of substitution becomes a composition of substitution. Semicolon J. Go. The selected string equal colon SS4 is the syntax that reads out the SS4 file variable. In PythonSf, file variables and customized files are ways to reproduce or reuse calculated results. They are stored in a hard disk drive. Semicolon A executes a line string under the cursor as a DOS command, like this. Semicolon A, go. The SS4 file exists at the current directory. Let's look into contents of the SS4 files. Semicolon A, go. The contents are the strings created by Python pickles. Adversely, colon equal generates a file variable. Semicolon J, go. Semicolon A, go. There is sbtemp.pvl file in the current directory. The sbtemp file variable equal to the SB2301 substitution. Semicolon J, let's go. PythonSf one-liners are accumulation of thoughts. File variables or customized files are essence of thoughts. You can restart your thoughts from the essence. You can learn SS4, i.e. substitution group SN4, that is existing at the current directory. You can restart to learn about SN4 by SS4 file variable. Let's check some more usage of the SS4 file variable. Substitution 1, 0 doesn't belong to SN4. But Substitution 1023 belong to SN4, semicolon J, go. Yo. You can create a group that is generated from 3 substitutions, semicolon J, go. Originally, the SS4 file was created. This PythonSf expression. Go. PythonSf has implemented a function returning a coset for division of the SS4 class. So you can get the coset by this PythonSf one-liner. You can also calculate conjugacy classes, solvable groups, and etc. for SN4. Let's go. Semicolon J, let's go. Yoi!